This question says that weights of newborns are normally distributed with a mean of 3,420 grams and a standard deviation of 495 grams. Question A asks, what is the probability that a randomly selected newborn weighs less than 2,100 grams? First, let's look at the relevant information in this problem, and let's collect all of the things that could help us solve it. First, we are told that this is normally distributed, which means most likely we'll be using some form of either Norm.dist or norm inverse. We are also given that the mean is 3,420. That will be useful. And the standard deviation is 495 grams. That will also be useful. So really our main task is to decide between Norm.dist or norm inverse. Now we can use Norm.dist if we have a mean, a standard deviation, and an x value. We can use inverse if we have a mean, a standard deviation, and a probability of being less. If we don't have a probability that's less, but instead have a probability that's greater, we'll first need to change probability of being greater into less before we can continue. But now when we look at question A, we see that we have a value of 2,100 grams. That is not a probability, that is an x value, which means we'll be using Norm.dist this time. We'll need the mean, the standard deviation, and the x value. The mean is 3,420. The standard deviation is 495. And the x value is 2,100. Based on this, we can find p less, or the probability of being less than 2,100. Now in the problem, we are asked about being less than 2,100, so we will not need to add an additional step and find the probability of being greater. We can go straight to the Norm.dist formula here. We'll need x, mean, standard deviation, and then the word true. So let's type equals Norm.dist into the box. Click x, comma, mean, comma, standard deviation, comma, true. And so our probability of a randomly selected newborn being less than 2,100 grams is 0.00383. That will be our answer for this problem. Now, part B is a fairly similar question. They ask us for the probability that a randomly selected newborn weighs more than 3,600. Once again, we have a mean, a standard deviation, and this 3,600 is not a probability, it's an x value. Instead, they ask us to find the probability as the answer. So once again, we can enter the mean, standard deviation, and x value. Based on this, we can find probability of being less. However, in the question, we are asked for being more than 3,600. If you see the word more in the question, that's the same as saying greater than. And because of this, we'll have to add an additional step after p less, and we'll have to find p greater. Now, p greater is always 1 minus p less. So let's add another line for it. Now we enter the mean, 3,420, the standard deviation, 495, and the x value, 3,600. Once again, to find the probability of being less, we do Norm.dist, and then say x, mean, standard deviation, true. We'll enter equals Norm.dist, Click the X, comma, mean, comma, standard deviation, comma, true. We've now found our probability of being less, so all we need to do is take 1 minus that to get p greater. So we'll say equals 1 minus and then click p less. So the probability of being greater than 3,600 is 0.358065. That will be our answer for this problem. In the next problem, we still have a mean and standard deviation given to us, but now we are also given two x values. If we have two x values, we can find the p less for both of them. And once we find those, we can subtract the higher minus the lower. So let's enter the x values we were given. We have 2250 and 3650. The mean will be the same for both of them, 3420. The standard deviation will also be the same for both of them, 495. Based on this, we can get the probability of being less than each of these x values. Once again, we'll use Norm.dist, and once again, x, comma, mean, comma, standard deviation, comma, true. So we say equals Norm.dist, click the x, comma, the mean, comma, standard deviation, comma, true. Press enter to get p less for the 2250, and use the black cross and move it over to the side to also find p less for the 3650. So now we have p less for both of the x values. Now we can get the probability of being between them. We'll say equals, click the higher value, subtract the lower value. And so we get 0.669859. That will be our answer for this problem. Problem D says, in 2008, a hospital noted that a baby had been born there weighing 4,608 grams. Is this weight usual or unusual? Now remember, in order to get the unusually high weight, we take the mean and add 2 standard deviations. To find the unusually low value, instead of saying plus 2 standard deviations, we say minus 2 standard deviations. So let's first enter the mean and the standard deviation. Based on that, we can get the unusually low value and also the unusually high value. We enter our mean, 3,420, and our standard deviation, 495. The unusually low value will be the mean subtract 2 times the standard deviation. And then the unusually high value will be the mean, and then add 2 times the standard deviation. Now let's draw a picture based on this. We'll draw our bell curve. Our mean was 3,420. Our unusually low value was 2,430, and our unusually high value was 4,410. The baby in question is 4,608. Now 4,608 is definitely higher than 4,410. That would appear over here. Now, anything in the middle between these two numbers is usual. On the right, you have unusually high numbers. and on the left you have unusually low numbers. Now, we can tell our green mark is in the unusually high region, so we can say that baby was unusually high in weight.